Okay, 8th graders, we're going to start going through the lessons in Chapter 7. And in Chapter 7, we're going to be talking about solving a system of equations. In most of the lessons, we're going to try to find the solutions, which would be the values for the x and the y, that would make more than one equation true. One of the ways that you can use to solve a system or a group of equations, for example, these two equations, is to graph them and to find if they intersect, and if they do, where do they intersect? Because the line gives us all the solutions for the equation, and where they intersect would be the solution for both equations. Okay? So, take a look at this first example. We're going to graph the equations. We're going to identify the point or the coordinates where the lines intersect, and then check the solution. Okay? We're starting with two equations. One, y equals 2x minus 3. Okay? How would you graph this? It says graph the equations. How do you graph an equation like this?
Start at negative 3, the y-intercept. Yeah,
the y-intercept is negative 3. Then what?
You start at negative 3.
So there's negative 3.
You go up 1, up 2, and over 1.
Good. Up 2 over 1. So that's the next point. Now, one of the things that's helpful when you are going to solve an equation by graphing, or solve a system by graphing, is to mark more than one point on the line. So if you keep following the slope, it goes up 2 over 1, up 2 over 1, up 2 over 1, or we could go down 2 and left 1, because those are both negative moves, and that equals a positive slope also. So down and left are also positive, right? Now, the second equation, y plus 1 equals x. What do we have to do to solve that?
Make y by itself.
Good. It's a y by itself, which is what we worked on yesterday in solving equations.
Add negative 1.
Add negative 1 to both sides.
You get
So y is, look up here, y is 1x minus 1. Then, how do you solve that, or graph that?
go down 1. Or down 1 on the y-intercept.
Good. This is the y-intercept, so we go down 1.
Then you go up 1 over 1.
Good. Up 1 over 1, up 1 over 1. And you can see that at this point is where they cross.
Up 1 over 1.
So you write the coordinates of that point, 2 comma 1, and then take those coordinates and put them into both equations, into the original equation. So, put 2, 1 in for the x and y. So right here we put 2 in for the x, and 1 in for the y. And does it make it true? 2 times 2 is 4, minus 3 is 1. That's true, right? And
The most basic
2,
acronym
1.
ever.
1 plus 1 is 2.
No
Yes, it
way.
So,
2 plus 2 equals
we have the
6.
solution.
This
So we
man
found it
deserves
by
a cookie.
graphing. Okay? Take a look at the worksheet I gave you. You're going to do these for tomorrow.
Ooh, 3 answers.
Yep.
Hey.
3 answers.
Did you steal
You
my
now have to pay
pen?
for them.
Miss Munsky?
Number 1. 3x plus y equals negative 1. And x minus y is negative 3. We have to graph both of these. So, start with the first one. 3x plus y equals negative 1. How would we have, what would we use to graph that?
Y by itself.
All right, you get the y by itself.
Add negative 3x.
By both sides.
Yep. Then what do you get?
You get y equals negative 3x minus 1, or plus negative 1.
Okay? So start at the y-intercept. 22.
Dead here.
So what's the y-intercept, Bailey? No. Negative 1. See? Negative 1. What's the slope?
The slope is
Not negative 3x, just negative 3.
negative 3.
So you start at negative 1, and then how do you get to the next point?
You go down 3 and over 1.
Yep, down 3 and over 1. You could also go up 3 and left 1. And up 3 and left 1. And you want to mark as many points on your graph as possible. So follow the slope and mark those points. Okay?
Thank
Now,
How did you get that for
Yeah.
1?
for 1.
Yeah, the 1 x minus y equals negative 3. How'd you do that?
Well, we'll start with x minus y equals negative 3 up here.
Oh, wait.
Now, this one is in standard form. Remember when we learned about standard form equations? Yeah.
Oh,
And where we find that the x and the y intercepts? Yes.
I remember. I know what you did.
Or we can find numbers easily that equal negative 3.
Negative
For example, if x is 1 and y is 4, that equals negative 3.
What?
Remember, we
Minus
don't
sign.
have to always put them into slope-intercept form to graph them. You can also find 2 points that fit the equation. So, this point fits that equation, 1, 4. What else fits that equation? Zero and 0 minus 3 equals negative 3, right? So 0 and not negative 3, 0 and positive 3.
Hey, Doug. I know how we got the graph on 1. So you see how y is negative? You have to make it positive. So you put negative 1y divided by negative 1. And that's negative 3 divided by negative 1, which makes it positive. Both are positive. And then the
Okay.
Yeah.
So when you graph those, draw the lines and take a look at where they intersect.
I totally did.
Okay?
Team effort.
Where do they intersect, Christina? What are the coordinates where they intersect? We're number 1. We're still on number 1. Negative 1, 2. When you graph these equations, they intersect at negative 1, 2. So now we check. Negative 1, 2. Does that fit the first equation? 3 times negative 1 is negative 3. Plus 2 is negative 1. That checks, that's true. And negative 1 minus 2 is negative 3. So we have our solution. Okay? Any questions on that one?
Can we just get you for our assignment?
You can do 2 for your assignment.
And that's it?
No. You can start by doing 2 for your assignment.
Can we make
Do
2
you
our
know,
only
do you have
assignment?
any questions about graphing these 2 equations? Finding the solution.
Dylan, challenge
And checking
yourself to not fail.
There's nothing in this that you can't do. We have learned how to do everything in this lesson.
I need Shiloh.
Graph lines. If you need to solve, you can solve for y. You can check solutions. You can find the slope and graph the slope. You can identify the coordinates of a point. So there's you know how to do all of this. Take your time, think through it, and if you don't find a solution, then think about what we talked about yesterday. What if they're parallel? Would there be a solution? No. What if they're the same line? What if the lines, what if the equations give you the same line? What if both equations end up giving you the exact same line? Then how many solutions would they have? An infinite number. They're all the same solutions, right? So look for those cases as well. Parallel lines have no solutions because they would never intersect. And if the equations give you the same line, then they would have an infinite number of solutions. Okay? So finish both sides for tomorrow.